Okay, this is the video for 5.1. We're talking about the fundamental identities. These, along with the definitions, are your most used tools in this class. We already talked about the first three, the reciprocal identities, meaning that cotangent, secant, and cosecant are the reciprocal of sine, cosine, and tangent, meaning you flip them upside down to get this. This is one way of writing it. 1 over tangent means I've taken tangent and flipped it, to find the reciprocal of that. If tangent was, the tangent of an angle was 1/2, we would take the reciprocal to get 2 over 1, or just 2. The ones we didn't talk about in our last video are these quotient identities, and these are super important. Mainly, again, this first one. Tangent is sine divided by cosine, and that is super important. We were looking at completing a table last time of trig identities, or standard values for our trig functions. This is how we would do tangent, and I've got that written down here below. So let's see here. Just some fraction rules. You can kind of see the simplification I'm doing on these problems. I've got a review of those rules here with letters, which may or may not be helpful to you. I'll briefly run through it. I've also got it with numbers right beside it. So the first rule of fractions: when you're dividing a fraction by a fraction, the fraction on bottom, so in our case jk or j over k, that one gets flipped upside down. I'm really big on flipping things upside down in this class. So the first fraction, a over b, stays a over b. The second fraction flips upside down, and then you could multiply that straight across. And that's what I do over here. I'm dividing by square root of 3 over 2, so I flip that upside down. It's 2 squared over 3, and then multiply straight across. However, this simplifies, because I've got a 2 on top and a 2 on bottom. Those cancel out, and I'm left with the 1 and the square root of 3. And this is a review of the rationalizing a fraction, like we talked about in the very first video, 2.1, I think. The root on bottom, square root of b in our case, gets moved to the top, and we leave whatever was underneath that root, in our case b, we leave that on bottom. So I've got this example. I think we actually did this example in the last video. So that's just to review the rules so you can see how this table is completed. We did sine and cosine earlier. I've got the simplified versions. I want to show you what happens when we use our reciprocal identities. So did I say reciprocal? I mean the quotient identities. Okay. So the very first one, tangent is always going to be sine over cosine. So if I take my first number 0 and divide it by 1, that gives me the tangent of this angle. 0 divided by 1, and that simplifies to 0. Same thing for 30 degrees. I take sine of that, which is 1/2. I divide it by cosine, which is square root of 3 over 2. 1/2 over square root of 3 over 2 simplifies to this. Okay. So I'm going to highlight these. I'm just going to highlight the simplified version, because that's the one we want. The rest is just how we get to that. So we could just continue down this table by taking the sine, dividing it by the cosine, and that gives us this. For the rest of this, again, just these reciprocal identities. I filled it out for secant. Secant is the reciprocal of cosine, so I go to my cosine column and I just flip all of these fractions. So 1, when I flip 1, I just get 1 again. Square root of 3 over 2, when I flip that, I get 2 over the square root of 3. And you can simplify that or not. Again, I'm not a big stickler on this. Lots of other people are. When I take square root of 2 over 2 and flip that upside down, I get 2 over square root of 2, and that reduces like so. and so on down our list. 1/2, I flip 1/2 upside down, I get 2. I flip 0 upside down, I get 1/0, which is undefined. Okay. And you can complete this table the same way for the other two. We don't use cotangent, secant, and cosecant a lot, so I didn't fill those out. It is good practice for you. I would try to do it just so you can get comfortable with flipping these fractions upside down. So cotangent, for example, could be done 2 different ways. According to our quotient rule, the quotient rule says cotangent is cosine over sine. So I can go over here, I could take cosine and divide it by sine. I could take cosine divided by sine. I could do that for each step on the table. Or I could use the reciprocal identity. And the reciprocal identity is very nice. Whoa. The reciprocal identity says take tangent and flip it upside down. That's our first reciprocal identity. And that's nice because these are already simplified. I flip 0 upside down, I get 1/0, so that's undefined. I take square root of 3/3 and I flip that upside down. Control 2. So I get 3 over square root of 3. And you could simplify that however you like. Ooh, it simplifies nicely, doesn't it? Yeah, that simplifies to just square root of 3. I could take, where's my button here? I could take 1, flip it upside down, I still just get 1, and so on down the table. So that's all we're going to cover for 5.1 for now, these identities. This is the only way I find cotangent, secant, and cosecant is by flipping one of our other well-known functions upside down. And the quotient identities are super important, but mainly I'm interested in the tangent for those. Pythagorean identities we won't cover just yet. They're super easy. So that's it. Thanks for watching, and I'll see you next time.